Let's begin this block on routing for IPv6 by taking a look at certainly a way that we can route on the equipment, and that is static routes. The manual configuration of route information in the routing tables. You may think, when would I ever do this? We know there are many times that static routes are going to become important in a configuration. We'll see them in tunneling configurations. We see static routes in maybe a branch office headquarters type configuration where we don't need the overhead of a routing protocol. Incidentally, we must be careful with static routes in the CCIE lab exam. Many times they are completely prohibited except if explicitly stated we can use them. So let's read the overall rules about static routes, and then let's be very careful to look for wording in the exam that indicates we might need to use them. Here you can see the v6 static route syntax, and it follows very much from v4. Instead of IP route, we say IPv6 route, and then we specify the prefix and prefix length, and then we'll specify either an interface, a next hop IPv6 address, or both. In addition to this, we have the administrative distance value that we can assign, and some additional keywords like unicast, multicast, or tag. Those will come up where appropriate in the particular VODs. So let's take a look at a directly attached static route syntax. We say IPv6 route and then the address and prefix length. In this case, I'm saying 2001 CC1E/32 is the prefix we are interested in training the router how to get to. Here, because we're using a directly attached static route syntax, all I say is, you know what? In order to get to this particular prefix, go out serial 0/0/0. The destination, therefore, is assumed to be reachable right out this interface. So notice we don't specify a next hop. The packet destination address is used as the next hop. In order for this static route to be valid and installed in your v6 routing table, the interface must be in the up state with v6 enabled on the particular interface. Another option would be to do a recursive static route. Here you can see I'm specifying destination prefix, but I'm saying to get there, go ahead and take the next hop 2001:12::1. So we provide a next hop IPv6 address. It's called a recursive static route because what the router will now do is when this destination is triggered, when this destination is seen in the incoming packet, it will then take a look at its routing table and determine the appropriate interface based on the next hop address. In order for this static route to be valid then, the router's gotta be able to do this. It's gotta take a look at the next hop of 2001:12, and it's gotta be able to figure out what interface is appropriate for this particular traffic. A fully specified static route includes both an interface reference as well as the next hop reference. So here I've got the same prefix, but I'm saying to get to this particular prefix, use the Ethernet 0/0/0 interface, and oh yeah, by the way, out that particular interface, you'll be looking for a next hop of 2001:12::1. This is ideal when the output interface is multi-access, and there could be multiple next hops reachable out that particular output interface. Also, floating static routes are still around in IPv6. You're probably familiar with these from a v4 routing environment. With a floating static route, we do a neat trick. We give an administrative distance for the static route, and we provide an administrative distance for the route that is higher than the administrative distance that would be found for a dynamic routing protocol method to get there. This is a nifty trick indeed, and can be used as a backup to a dynamic routing protocol. You see, this static route will not be installed in the routing table unless the entry for the dynamic routing protocol is missing. If that goes missing because we have a link failure or something along those lines, then this route with the worst administrative distance would be installed in your routing table. So it's a cheap, efficient way to do backup routes. Well, let's go ahead and experiment with some static routes between R1 and R2, what I've tried to build here is get you thinking of like a headquarters to branch office type situation. Notice here at headquarters, represented by R1, we have several different V6 networks, and then we're connected via a point-to-point serial interface to R2. R2 is a little branch office router in this case, and notice it only has one V6 network out there other than the link to headquarters. So what we'd like to do is configure full reachability in this topology using static routes. Let's start on R1, the headquarters router. We'll enter global configuration mode and we'll say, alright, we want to turn you into a V6 router. We'll use the IPv6 unicast-routing command. Next, we need to train R1 how to get to that single network off of R2. So I'll say IPv6 route. I'll say the network is 13/64. And we'll say it's directly attached. We'll say just take traffic and send it out serial 1/0 in order to get to that network. And guess what? We are done here on R1. We can verify this configuration with the show IPv6 route command. And what we're looking for in the V6 routing table is to make sure we have a static route entry that instructs the router how to send traffic to the 13 network. Let's go over to R2 now. This is the branch office router. And on R2, I'll say IPv6 unicast routing. You are now a router for V6 traffic. And on R2, what we're going to do is we're going to use a default static route. We're going to say, look, there's lots of networks that are attached to headquarters. In order to get to any of them, just send your traffic out the serial 1/0 interface. So I'll say IPv6 route ::/0. We're saying this default static route syntax is that any network, and we specify any network using simply : :/0. And now I'm going to say, go ahead and send the traffic out serial 1/0. Alright, so there's our V6 route for a static route. If we don't have awareness in the routing table, how to get there specifically, go ahead and use this default static route. If I do a show IPv6 route, we will see that default static route in the routing table, and that should provide reachability to any of these networks over on R1. So we're ready to test. We'll go to R1 and I'll say ping 13.13.1. Can we reach the network that is out there at the branch office? Look at that, we sure can. It's perfect. Let's go over to R2. Can we reach the 11 network? Yes, we can. And if that worked, I'm feeling good about the 10 network. Can we reach the 10 network? We sure can. So here we completely provide full reachability between headquarters and the branch office, all with using just a couple simple static route entries.